Welcome and hello. This is a lesson in WRIMS, and in this lesson, I'm going to be discussing channels, diversions, and constraints. So, the first part is going to involve channels and diversions, those are decision variables. And then part two will be constraints, specifically continuity and the maximum diversion. All right, so let's go ahead and get started. What I have on the screen here is my WRIMS interface. I've already created a project here for lesson 6, channels, diversion, and constraints. So let's go ahead and open that up. This is a continuation of lesson 5, where we talked about inflows and demands. And then the last part of this 3-part lesson will be 7, where we talk about objectives, populating the main.russell file, and then running the model. So channels and diversions is what we'll start with. Now, what I already have in my run directory, there's a system directory. This is where we have defined the demands and inflows. I'm going to now define a couple more elements, specifically channels and diversions. So where we are on the map schematic is shown here. We have inflow entering node 1. We'll say this is river A. It flows from node 1 to node 2 to node 3 and then exits node 3. Downstream of node 3, that's sort of out of the area of interest. At node 2, we have a diversion that serves a demand over here at a farm. And the 3 variables that we're interested in this lesson is C12, C23, and D24. The C just basically identifies that variable as a channel flow, and then D identifies that flow as a diversion flow. Of course, the numbers represent the starting node and the end node as far as the direction of flow. Okay. So let's go ahead and define those 3 variables in a channel file as well as a diversion file. Look in WRIMS, I'm going to come over here to my project 6. I'm going to click on System and then right-click, New, File. Now the name of the file I want to add here is going to be arcschannels.russell and then finish. Okay, so that's been added. And one more I want to add is going to be called arcsdiversion.russell. So new file, and down here, arcsdiversion.russell and finish. All right, so those have been added. It looks like they're alphabetical. It also looks like they open the file here in the IDE. So we don't need inflows or demands. For arc channels, I'll select that one and then type in or paste in the code as I've done here. What we have is we've defined a variable for the flow rate in channel C12 and then channel C23. The kind right here, this is going to be part C in the path for the decision variable. The output in the .db.dss file is called channel, and then the units are going to be in CFS. I'm going to do a similar operation for the diversion now. So I'm going to select the arcs diversion and then paste in the variable D23, which is the flow rate in the diversion from node 2 to node 3. Again, it'll be channel for part C, the kind, and then the units will be in CFS. Okay, I'm going to go ahead and save that and then save channels as well. I mentioned these 3 flow variables are decision variables, so I don't know what the actual flow is going to be. What we'll do is we'll feed WRIMS the boundary conditions, the constraints, the objectives, some things we haven't even created yet, as well as the inflows and the demands. And ultimately, it will be the linear programming solver engine built within WRIMS that will determine what the actual flow rate is through channel C12, channel C23, and then the diversion 2, 4 as well for every time step in the simulation. Okay, the Russell Plus language guide also talks about decision variables here. So I'm just going to reference this briefly, but there are continuous decision variables. That's what we've created. The STD keyword here indicates that the variable will have the standard LP non-negativity bound and an upper bound of 1E38. We can also create bounds within our decision variables by using keywords like lower or upper, or even unbounded if there's no bound. And then below that, we have binary decision variables. That's another type. And lastly, integer decision variables. In the case that your decision variable is either a 0 or a 1, or you know for sure that it will be an integer. So that's the channels and diversions. The next part of this lesson, I want to talk about constraints. So let's revisit our model schematic once again. We're going to have 2 different types of constraints. The first will be continuity, where at node 1 and node 2, we need to specify that the inflow minus the outflow equals the change in storage. So in the case of node 1 here, we're going to have inflow I underscore 1 minus the flow in channel C12 is going to equal 0 because there's no storage at these nodes. These nodes are just nodes. They're not reservoirs that can lose or gain storage. Similarly, down here at node 2, we're going to say C12 minus the flow out of D24 and C23 is going to also equal 0. Okay, so that's the continuity constraint. We'll see that in code in just a moment. And then the last constraint will be a constraint on this diversion flow. So whatever the demand is, we're basically going to set it to be the ceiling for this diversion flow. We're not going to divert more water from the river than is demanded. Okay. If there's any extra water in the river after the demand is satisfied, it will continue flowing downstream through node 3. Okay, let's go ahead and go back to our RIMS now. Just like channels and diversions, I'm going to add a couple more files here, Russell files, to our system. So new file. This time I'm going to call it constraints connectivity.russell finish. And one more, right click on system, new file, and the name of this file will be constraints diversion.russell and finish. Okay, so those two opened up. Let's go ahead and get those open on the screen. Starting with constraints continuity right here, paste in the two variables. We're going to have continuity at node 1 and continuity at node 2. The terms continuity and connectivity were somewhat synonymous to me. These are the actual terms and variable names used in the Springfield example. So I'm just kind of adopting that language at this moment, but I may adopt my own way of thinking about it and only call it continuity, for instance. But anyway, the file is named connectivity. The variable name is continuity. And this is our inflow minus outflow equals 0 for node 1. And then for node 2, we have our inflow minus the outflow equals 0. All right. So I'll Control S to save. Come over here to constraints diversion file, and I'm going to paste in that constraint. It's called constraint D24, and it basically says the flow through that diversion is going to be at most the demand. The demand is AW underscore farm. That was mentioned in lesson 5 where we talked about demands. So go ahead and check out that video. And then in the next video, we will tie it all together by editing the main.russell file and run the model and see how this all ties together. Okay. Also wanted to mention that this keyword goal does not refer to an objective. It refers to a constraint, either a hard constraint or a soft constraint, you may say, a constraint that can be violated, but there is a penalty involved if it is. You can read more about the constraints in the Russell Plus language reference document. Here it is. The goal statement is used to specify system operating constraints. Hard constraint is if the LHS or RHS or the constraint is used instead of the word penalty. But if the term penalty is included, for instance, right here, we have the word constrain. Here we have the word penalty, in which case it would be a soft constraint. There's also conditional goal statements right here. So I just wanted to point out that pages 17 and 18 contain information about the constraints. So I'm going to go ahead and save this. That same language reference also mentions that this less than symbol is really the same as less than or equal to, or rather at most, the same way a greater than symbol is used synonymously in RIMS as at least. So just keep that in mind. If you see a less than or greater than symbol in one of these constraints, it really means at most or at least. Okay, so that's it for this lesson. What we talked about were channels and diversions, which were decision variables, as well as constraints, both continuity and max diversion.